Okay, so here are the notes for section 11.3, areas of, areas if, Mr. Moyer, areas of circles and sectors. Dang it, typo. Um, so yeah, we've found circumference already. Now we're going to find areas of circles and then also areas of sectors, which we'll talk about what those are when we get there. So areas of circles. I think I'm gonna have an easier way for you in section 11.4, but we haven't gotten 11.4, so I'm gonna go kind of walking through the way the book does in 11.3, how they derive the formula for area of a circle. It's kind of a crazy way to do this, but they take a circle, okay, and they say let's break it up into a bunch of little like slices of pie, little pieces of pie here. And then what they do is they take this little piece here, and then they put it right there facing up. And they take the one next to it, they turn it and make it face down. And they keep doing this over and over again. This one faces up, you face down, over and over and over again until they get this shape here. It looks like a parallelogram. Now, the thing is right now it's obviously curved, but if you could think about like taking like infinitely many of these guys, like so they're so thin they're basically a segment, what you'll find is you get this parallelogram shape. And what happens is since every other one is one's going up, one's going down, one's going up, one's going down, one's going up, like so this one here is down, this one's up, down, up, down, up, down, up, down, up, down, up, down. Half of them are going up, half of them are going down. So it means half of the circumference is here, but the ones going down, and the other half of the circumference is the ones over here going up. So the formula is for area of a parallelogram, 1/2 base times height, or just base times height. Okay, so base times height would be then base, which is 1/2 c, times height, which the height then ends up becoming the radius of this guy. That's the radius. So 1/2 circumference times radius, where circumference is 2 pi r. That becomes 1/2 times 2 pi r times r. The 1/2 and the r, or sorry, the 1/2 and the 2 cancel off. So I get pi times r, which is pi r squared. So that's one way to kind of verify the formula of the area of a circle is 1/2 pi r squared. Okay. Like I said, I'll have another one in section 11.4 that I like a little better. I think it's easier to see than this guy here cutting it all up. But that's the first way to kind of walk through it. So formula for area of a circle is pi r squared. So here we go, first problem. An outdoor accessories company manufactures circular covers for outdoor umbrellas. If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. This one's not so tricky as much as you have to be careful. Okay? Because the temptation is to go, oh, area of a circle, well 8 plus 72, that's 80 plus 8, 88. The problem is that 88 inches is the whole distance across. That's the diameter. Area is pi times r squared. So I need the radius. So I need to divide that by 2 to get the radius. So 44 is the radius. So area equals pi times 44 squared. That's the exact answer, whatever 44 squared is times pi, but it'd say it in square inches. So let's get our calculators out. Pi times 44 squared is 6,082.1. Yeah, 6,082.1. If I wanted exact answers for this, whatever 44 squared is, (1,936 pi). So there's your exact answer, 1,936 pi inches squared. All right, next example. Find the radius of a circle with an area of 58 square inches. Okay, so we're working backwards here. So we're working backwards. So I'm going to find the radius of a circle with an area of 58 square inches. Well, area is pi r squared. And our area is 58 square inches. So the first thing we have to do is divide out the pi. So 58 divided by pi. 58 divided by pi. Which is 18.46. I always like to go a few places, at least two. So let's do 18.46 equals r squared. And now to solve for r, take the square root. Square root of 1846. So second square root, 18.46. 4.296, so 4.3 to the nearest tenth then. So, or 4.3, whoops, 4.3 inches is approximately the radius. Okay. All right, so the next thing we have to talk about is a sector of a circle. Okay, a sector of a circle. I like the way the book defines this. They really make it. They really kind of like make it nice and, I don't know, reasonable. That a sector is basically a slice of a pizza, slice of a piece of pizza in a circle. The way we really define it is, hey, if you've got a center of a circle. Okay. Whoops, let's not use that color. Let's use a marker like a grown-up. So here's your center of your circle. If you draw segments to the sides from the center, basically if you create a Pac-Man figure part, okay, this part right here is a sector, but actually so is this part out here. It's also a sector. It's just a big sector going like around this way. So you actually have two sectors here. But the easy way to think of it is like maybe like with a minor arc, the small sector. But again, a sector is a region of a circle. I should probably actually go through and highlight that for you. Region is a sector is a region of a circle bounded by a central angle and its intercepted major or minor arc. Okay. And the formula is similar to that of arc length, which is right here. Okay. So remember with arc length, it was I did, instead of A is the area of the sector, area of the sector over it would have been both circumference when we did arc length. Well, now we do area of a circle, so pi r squared for that equals the central angle over 360. That's how the formula works. So it was circumference. It was arc length over full circumference equals angle over 360. Same thing, but now it's area of the sector over pi r squared equals angle over 360. Or the area of the sector is the angle divided by 360 times pi r squared. So it's the same formula, but all I've done is replace circumference now with area. Okay, so here we go. First example. A pie has a diameter of 9 inches and is cut into 10 congruent slices. What is the area of one slice to the nearest hundredth? So here we go. Here's Mr. Moyer's poor attempt at drawing a circle. Okay, and so what we have is we have a pie, so you have like 10 slices in the pie. That's 8, and I don't know, maybe that. They're definitely not equal, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 slices in the pie, and they're congruent. That's the key. So the question is, what is the area of one slice? Well, I like to do this one, angle over 360 times pi r squared. It's the one I just prefer the most. So our angle, we could work that out. The thing is, there are 360 degrees in a circle. Each one of these is the same. So the angle is going to be 360 over 10, 36 degrees. Okay, so it's 36 degrees out of 360. Okay, times pi times r squared. Now, what might catch some of you is if you said, oh, this is 9, that's the radius. Diameter is 9. So the radius is 4.5, half of that. 4.5 squared. Okay. Now, the savvy among you might say, I didn't need to know the 36 degrees. In fact, I didn't even need to know the central angle. Why? Well, this is 10 equal slices. So what I'm just going to do is find the area of the whole circle and then divide it by 10 in the end, which is fine because what's 360 over 3 or 36 over 360? It's 1/10. So you were going to get that anyway. So the formula works every time, but you know, sometimes it doesn't hurt to just use common sense and say, oh, well, 360 over 36. Oh, or sorry, 36 over 360. Oh, that's 1/10 of the circle. So I'm just going to take the area of the circle divided by 10. And in fact, that's how I would do it on the calculator, but I wouldn't even mess with 1/10. I would just do 4.5 squared times pi, or pi times 4.5 squared, doesn't really matter. And then divide it by 10, which is 6.36. It did say nearest hundredth, so yeah, 6.36 square inches. So 6.36 square inches. Okay, last example. So another area of a sector problem. The key to this though is we're looking for the shaded area. So you gotta be really careful because some of you might be tempted to go, oh yeah, 65 over 360 times pi times 11 squared. Hold on. The shaded area is everything but the 65 degrees. So 360 minus 65 is 295. That's how many degrees this arc is. Sorry, squared degrees. So area is going to be angle over 360 times pi times 11. I'm sorry, times radius squared, which then in our case is 295 over 360 times pi times 11 squared. Now when you do this with your calculator, okay, put the 295 over 360 in parentheses. So parentheses 295 divided by 360 times pi times 11 squared, which is 311.5. Sounds good to me because that doesn't have any unit there. So 311.5 square inches. Yeah. All right. Double check that to make sure that's what I got. 295 over 360 times pi times 11. Yep. All right. There we go.